but so delicious. When I do my creative problem solving, I drink Dunkin' Donuts coffee. Oh my gosh, another nailed commercial. Someday, kids, I'm going to be making millions from Dunkin' Donuts. They're going to be like, oh my god, the Dunkin' Donuts mascot! Yeah! Alright, I'll never make millions, but I do enjoy drinking their coffee. Especially when it's fresh and hot. Yeah, it's really hot. Anyway. Oh, you guys thought I was talking about me? No, never mind. Shut up. Anyway, let's get going. Chapter 1. We're gonna be starting this chapter. Now, in this chapter, what we're gonna be talking about is these things called. Let's get the purple going. Systemic. How about systematic lists? I think I need some more coffee. Ow! You guys might want to push like fast forward. I don't know if I'm gonna have like a crazy time, man. It's gonna be a weird video. I'm telling you right now. All right, so let's see what's going on. Leslie has 25 cents in her pocket. Oh my God, Leslie's so rich. She doesn't have a quarter. If you can tell her all possible combinations of coins she could have that add up to 25 cents, she will give you the money. So this is a systematic list. In other words, you're not just randomly going to start listing things. It's a system that creates the list. So we got to figure out how we want to do this. Now, clearly, there are only 3 different kinds of coins she can have in her pocket. She can have pennies, and we're going to go in order. Wow, that's a crazy good line. She could have nickels. Uh-oh, how do you spell nickels? Nickels. I think it's like this, nickels. We'll go with that. We're definitely going with that. And we can have dimes. So remember, we want all the different possibilities of coins in her pocket that add up to 25 cents. Now, it doesn't seem like there's a lot, but I think there are. So let's see. Let's start out with the idea that she could have 25 pennies, which would mean that she can't have any nickels and she can't have any dimes. Okay, not bad, kind of simple. Now, can I next go to 24 pennies? Again, we want to create a systematic list, so if I go to 24 pennies, could I have a nickel? I'll let you think about that while I drink. Of course not. If I had one single nickel, I'd be up to 29 cents. Okay, so maybe I can go to 23. Could I do this with 23? No, because a nickel would get me over 25. 22? Nope, I forgot 24. 21? Nope. How about 20? Can I have 20 pennies in my pocket? Sure. If I had 20 pennies in my pocket, then I could have one nickel, but no dimes. Okay. So for every what's I'm working for? For every for every 5 pennies, I obviously going to add one nickel. So I don't want to do 19, 18, 17. I want to go right down to 15. 15, I could have 2 nickels and no dimes. Okay. Now, staying with 15, I can stay with 15 here because also another way to get this, remember, for every 2 dimes, for every 2 nickels, that's really 1 dime. So again, this list is going to go down from biggest to smallest. These ones over here are going to do some random stuff. So I go 15 pennies, no nickels, but 1 dime. So that's 15, 10 is 20. Now, is there another way to do it with 15? I don't think so. So after 15, of course, we got to go down by 5, so we're going to go down to 10. Now, if I had 10 pennies, that would leave me 15 cents extra. So I could have a maximum of 3 of these, but none of these. So now I want to stay with 10. I want to try to stay with 10. Let me extend my lines here a little bit. Read and read. We're going to need a few of these. All right, let's go down to another 10. So if I had 10 here, could I have 2 nickels? Because that gets me 20 cents, and then I'd have, wait, no, 1 dime would take me over 25 cents, so that's not going to work. Remember, you got to take 2 of the middle out in order to get 1 over here, right? So what I can't do 2 nickels, but I can do 1 nickel, because that would be 10 cents plus 5 cents is 15 cents. And now if I add 1 dime, I'm at 25 cents. Is there another way to do 10? Could I do 10, 0, and what does that leave me? 15 cents? Could I put something here that will get 15 cents? I can't. So that's it for 10. After 10, we're going to go to 5. Now 5 is going to get a little bit more interesting now. If I did 5, that's 5 cents. That means there's 20 cents left over. So that means I could do 4 of these and none of these. I can do 5 again. 5, that means can I do 3 of these? Wait, 5 cents plus 15 cents is 20 cents. Nope, that doesn't leave me enough. So for every one, you got to take 2 away in the middle to get 1 back for the dime section. So 2 nickels away to get 1 dime. So I'm going to go 2 nickels and 1 dime. Then I can go 1 more 5. I can go 5, no nickels, and 2 dimes. All right, after 5 pennies, we're going to go to 0 pennies. So if I go 0 pennies, let me extend these just a little bit further. Wow, that really printed terribly. If I go 0 pennies, that leaves me 25 cents. Well, I can't make 25 cents with all... Wait a second, 0. Hold on. The most I can do is 5, right? I can do 5 nickels, so 5 nickels would be 25 cents, but you'd have nothing left over for dimes. Do another 0. Now, another 0, I would have to take 2 away in the middle to get down to 3. That'd be 15 cents. That would mean leaving 1 here. Or I can take 2 away in the middle, get 1 nickel, and 2 dimes. So that's all the different ways. It's probably a lot more than you thought. You probably thought there weren't that many. If you were to try to do it unsystematically, you wouldn't find it. Now let me write myself a little sentence here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 ways to make 25 cents. Something like that. All right. I'm going to take a little break. I'll be right back. Dealing with coins makes me thirsty. Dunkin' Donuts, another nailed commercial. Oh, every time I take a break, it's a commercial. Anyway, here we go, kids. Let's see if we can highlight what's going on here. We got a Modern Basketball Association. There's a new basketball league that's formed. There's 3 in which each team will play against 3. Oh, we already did one like this, right? The Antelopes, the Bears, the Cubs, the Dusters, the Eagles, the Foxes, and the Goats. But this time we're going to create systematic lists. Last time we looked at this in Chapter 1, we did it using drawing a picture. This time we're going to use a systematic list. So, let's do it this way. I think, if you remember, I don't remember what the answer was. I don't know, it was crazy. So let's do it this way. Obviously, we got A, B, C, D, E, F, G, H, I, J, K, L, M, N, P. Oh, no, okay. So here's how it's going to work. A will play B. Now, of course, B already played A then, right? A will play C. A will play D. Again, we're creating a systematic list. I'm not just thinking A plays B, B plays C, C plays A, F plays G, G plays P, whatever. I'm not doing that. I'm going to create a nice systematic list. A plays E, A plays F, and A plays G. So how many is that? 1, 2, 3, 4, 5, 6. 6 games. Okay. Now let's talk about B. Oh, yeah, we want to talk about B. Them Bears are crazy. But B's already played A, so B doesn't have to play A again. B has to play, the first team B has to play that's new is B plays C. You'll notice there's no B and C over here, right? Then B's going to play, oops. Then B's going to play, okay, jerk. Now B is going to play D. B is going to play E. B is going to play F. And B is going to play G. So there's 5 games. Now let's go find out what C is going to do. Oh, I already used that pen. C is already played, let's see, C's already played A. C's already played B. So the first new game that C has to play is against D. Then C has to play E. Then C has to play F. And then C has to play G. Now, I understand that you already have the pattern here, but we're still going to finish this list to make sure we cover everybody. And when I ask you for a list, I want the whole list. It's kind of going to be a pain in the neck. So now we're going to do D. Well, D's already played A, D's already played B, D's already played C, so the first person D has to play is E. Then D has to play F. And then D has to play G. And let's go with black. Now we're going to do E. E has to play F. Oh, wait, this was 4 games. This was 3 games. E has to play G. G, that's a bad G. G, and there's 2 games. And our final game, oops, that's behind my head. So I'll just have to move that over for you. Our final game is, we got to start with F. F is going to play G. G, that's a bad G. And that's 1 game. Now, we don't even have to start with G, because by now, G has played everybody. G played F, G played E. No, wait. Yeah. G played F, G played E, G played D, G played C, G played all of them. So how many games is that? Well, we already talked about that before. 6 and 5 makes 11, 15, there's 5 more. That's 20, 21 games. So 21 games for 1 round. Now, I think they asked for 3 rounds, right? How many? Each play 3 times. So I would just do 21 times 3 equals 63 and say there will be a total of 63 games played. Boom. All right, let's move on. Penny has 25 dimes. She'd like to arrange them and order them into 3 piles, putting an odd number of dimes into each pile. And how many weight? What? So Penny's a little weird. Penny wants to play with her dimes. It's really weird because her name's Penny, but we're playing with dimes. You think Penny would want to play with pennies? Penny doesn't want to play with Penny. Penny wants to play with dimes. Woo! So, we got to figure out what's going on here. This one's going to get cray quickly. I think the answer to this one's like lots. So, let's do this. Let's number our piles. We got pile 1. Pile 2. And pile 3. All right, so how are we going to do this? Let's start with the lowest number in here. 1. She can put 1 there. Now, wait, what? Arrange them into 3 piles, putting an odd number in each pile. So if she puts 1 here, and she puts 1 here, how many would that leave? That would leave 23. So I can do that. All odd numbers. All right, let's see if we can do this another way. 1 here, 2 here, that's 3. That would leave 22. Oh, wait a second. 2's even and 22's even, so that's not going to work. So I can't go, and I can't put any even number down, right? So let's just keep going with this. But still want to stay here with 1, but we need to, this one's going to go up, and this, oops. This one's going to go up, and then the last one's going to go down. So this will go up to 3. So now I've got a total of 4 pennies being used, or 4 dimes being used. That leaves me 21. Okay. 1, 5, 19. 1, 7, 17. 1, 9, 15. 1, ooh, this almost went back down to 7. All we're doing is going up in the middle and down in the right. So 11, 13. 1, this goes up to 13, and this goes down to 11. But wait a second. I already have that. Right? This one here is the same as this one here. So let's get rid of this one. It doesn't make any sense, right? Doesn't make any sense. Because it's the same exact numbers in piles. So the trick is, it said odd number, in how many ways can she arrange them into 3 piles, putting an odd number of dimes into each pile. But these two would be the same, so can't do that. So now what I want to do is I want to increase the first one to make it an odd number. So we're going to go 3. And then I'll go lowest here. 1. That's 4. 21. But wait a second. I think I have something like that. Yeah, isn't that the same as this one? Yeah, so we can't have that one either. So we're going to stay with 3. And then how about we go up in the middle, 3. And then 19. So can I have 3, 3, 19? Yep, sure I can. So again, I'm going to stay with 3 in the front. Again, this is a systematic list. You got to stay with it. I'm going to stay with 3 here. The middle's going to go up 5, and the end's going to go down 17. 3, 7, 15. 3, 9, 13. 3, 11, 11. Okay. And then we're going to go 3, 13, and then this goes down 9, but that's the same as this one, right? So we can't do that. And then once these two switch, like it went from 11, 11 to 13, 9, we know we're done with 3s at the beginning. Okay. Let's start with 5s then at the beginning. We'll start with 5. Now, which 5 did I have already? I have a 5 with a 3. And I have a 5 with a 1. So I can't use 5 with 3, and I can't use 5 with 1. And I want to start out in the middle with the smallest value possible. So I can't go 5, 1, and I can't go 5, 3, because I already have those. So the best thing I can do is 5, 5. So that's 10. That's 10. So that's going to leave me 15 here. And then I can go 5, 7, 13, 5, 9, 11. And then the next one will be 5, 11, 9, but you know we can't do that one. And then we're going to go, so that goes up to 7. Let's try 7. Now, we can't go 7, 5 because we already have it. We can't go 7, 3 because we already have it. We can't go 7, 1 because we already have it. So the first one we got to do is 7, 7. That's 14. This would be 11. And then I want to go 7, 9, 9. All right, so we started with 7. Now, the next one I want to do, let's just keep going. Pile 1, pile 2, and pile 3. So these keep going up, right? Up, up, up. So this was 7. So now I want to do 9. So 9. Now I can't do 9 with 1. I can't do 9 with 2. I can't do 9 with 3. I can't do 9 with, I can't do 9 with 1. Can't do 9 with 3. Can't do 9 with 5. Can't do 9 with 7. But I can do 9 with 9. 9 with 9. Now, 9, 9, that's 18. That would leave me 7. Do I already have a 997? Well, isn't that what this one here is? 997? So I can't do that. And now, if you'll notice, we're going to just start repeating itself. So we're done. We're done. That's all the different ways to do that. So I got to count these now. All the different ones. So 1, 2, 3, 4, 5, 6. We already get rid of these. 7, 8, 9, 10. Oops. 11, 12, 13, 14, 15, 16. So, Penny can arrange her 25 dimes into 3 piles, 16 different ways. Shabam! Done. I'm going to go drink some coffee. When I successfully arrange my pennies. Dimes! Dimes! Oh, sorry, Dunkin' Donuts. Please forgive me. I meant dimes. Her name was Penny. When I help Penny successfully arrange her dimes, I drink Dunkin' Donuts coffee. It's the best. God. How am I not a millionaire already? I don't even know. It's crazy. Cray cray! All right, here we go. On a famous episode of Star Trek, Captain Kirk and the gang played a card game called Frisbin. This is the problem. This problem is about another game called Frisbin. The object of Frisbin is to throw 3 frisbees at 3 different size bins that are all set up on the ground 20 feet from the player. If a frisbee lands in the large bin, scores 1 point. So large is 1 point. Medium is 5 points. And the smallest bin, you get 10 points. Captain Kirk McCoy is playing the game. I don't even know what that means. Kirk McCoy is playing the game. If all 3 of his frisbees land in bins, how many different scores can he make? Oh, this is going to be huge, humongous. All right, let's see. How about we start with this? Let's see what he can do for throw 1. We're going to need a lot for this one. What is that? Oh, God, I hate this. I wish there was a way to draw. Is there a way to draw just a straight line? Shapes. Line. Oh, look at that. Can I do it again? No. Control Z. Shapes. Line. Damn. Shape. Line. And then erase this. Ooh, yeah, that's right. Now we got to throw 2. And throw 3. All right, so let's see what we got. All right. Let's assume that on throw 1, he got it in the small bin, 10 points. On throw 2, he got it in the small bin, 10 points. And throw 3, he got it to 10 points. Now, wait a second. How many different total scores can we make? Oh, shoot. We're going to need one more column. You know what? This is too much. This is too big. I feel like this is too big. So I'm going to do this a little bit nicer, neater. And then line. Now that I know I can do lines. This makes me like so happy that I can do straight lines like this. You have no idea. I'm just like a really happy camper now. And I'll tell you why we need the 4th one in a second. All right, so throw 1, throw 2, throw 3, and then score. Now remember, all these scores have to be different. Can't have the same score. They all have to be different. So let's go max out. Yeah, let's start with a positive. 10, 10, 10. That's the most points you can get, right? 10, 10, 10, 30. 30 points. So that's the most points you can get by throwing those 3 frisbees into all the small bin. Okay. Now we're going to stay with that. Max out on the first one. Max out on the second one. But didn't quite max out on the third one. So that's 25. Then we're going to go max out on the first one. Max, what is it? 10, 5, and 1, right? So max out on the second one, and then 1. That would be 21 points. And then, let's see. How about we max out on the first one? Don't quite max out on this one. And then max out on the last one. But wouldn't that be 25 points? And we already have that, so we can't have that. So how about we have a 5? Can we have a 5? Yes, because that would be 10, 5, and 5. That would be 20 points. That's different. And then we'll max out on the first one. Not max here. And then minimum here, that'd be 16 points. All right. Doing so good so far. All right. Then we're going to max out on the first one. Minimum, and that would be 12 points. Now, I don't think there's anything else we can do with maxing out on the first one. So let's just stop that. Now we're going to go to, I'll just change colors now. Now we're going to go to 5 here. And then max. But that would be 25. And I know we already have a 25, so that's not going to work. How about a max, no, a 5, and then a max, and then a 5. Wait, that's 20. We already have that. And then 5, 10, and 1. We already have that as well. So I can't do 5, 10. How about 5, 5, and 10? That'll be 20. 5, 5, and 5. That'd be 15. That's new. And then how about 5, 5, 1? That's new. That's 11. And then how about 5, 1, 1? That would be 7. All right, we start with 5. We start with 10. We start with 5. Now we're going to start with 3. Start with, oh, not 3. Start with 1. And then can we go 5? No, wait, let's start with max again. 5, 1, 10, 10. That'd be 21. We already have that. Can't do that. 1, 10, 5. We already have that. 1, 10, 1. That's 12. We already have that. 1, 5. 5 is 11. Can't have that. 1, 5, 1. We already have that. So that's not going to work. How about 1, 1, 5? That would be 7. So it's just 1, 1, 1. 1, 1, 1, 3. I guess that's it. What do you got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let me just make sure. Yeah, it matches what I have in my cancer key too, which is good. So if he scores on all 3 frisbees, there are 10 different score outcomes. All right. What was that? Number 3? Number 4. Man, we're flying. 2 more. After a rough frisbee match, me and the boys, we go get us some Dunkin' Donuts. It's the best. Yeah, that little thing at the end, that was money. Woo! Money shot. There it is. Go for gold, baby. Yeah, that's going to be on the cover of Time magazine. So a rectangular has an area. Whatever, I don't even know what I'm talking about anymore. Too much coffee. Measures. A rectangle has an area measuring 120 centimeters. Its length and width are whole numbers of centimeters. What is the possible combinations of length and width? Which possibility gives the smallest perimeter? So we need length, width that are going to multiply the area, and then we're going to have to check out the perimeter. So let's just use this thing again. longer. Probably going to use longer. I didn't quite hit there. All right, something like that. Okay, let's see what we got. What we're going to have is length, width. We can check the area here. It should just be 120 all the way down. So I'm just going to put an area down there. That's 120. And then we want the perimeter. Perimeter. Boom. And we want that to be the smallest. So let's see what we got. Clearly we can go with 1 by 120. That's got an area of 120, but it would have a perimeter. Now we got to be careful. Remember, there's 2 lengths plus 2 widths for perimeter. So that'd be 2 of these, that'd be 240, and 2 of those would be 2, so that'd be 242. That's pretty big. How about 2 times 60? 2 times 60 is 120. Okay, now perimeters. 2 of the 2s and 2 of the 60s. So 2 60s is 120, so this would be 124. 3 times 40 is 120. 2 40s is 80, 86. So we're getting smaller and smaller. 4 goes in 30 times. That's 120. 2 30s and 2 4s, that's 68. What do we got? 5 goes in. Was that 24 times? 24 times? So 2 24s is 48, and 2 5s is 10, so that would be 58. My nose itches so much, I don't know why. 6 goes in 20 times. 6 times 20. So 2 20s is 40, plus 2 6s is 12, so that'd be 52. Clearly with some area of 120. 7 doesn't go in. Does 8? Yes, 8 goes in. 8 times 15. So let's see, 8 times 15 is 120. 2 15s is 30, and 2 of these is 16, so that's 46. Getting smaller. And then 9 doesn't, but 10 does. 10 times 12 is 120. And then 2 12s is 24, and 2 10s is 20, so that would be 44. And I believe we now have a winner, chicken dinner. So the rectangle with the smallest perimeter but has an area of 120 centimeters squared would be 10 centimeters by 12 centimeters. Period. Okay, one left, and we're done. Woohoo! Let's go. Which book should you read? Oh, goodness. To Kill a Mockingbird. Let's highlight these. To Kill a Mockingbird, that's one title. All Quiet on the Western Front. The Stranger. And The Adventures of Huckleberry Finn. And A Mid-Numbers Summer Night's Dream. How many different sets of 3 books can you choose? What? So, like, if you were to think about this and just randomly go through it, there's just 0 chance. You got to stick 3 books. So how many different ways are there to do that? Let's see. I'm going to try to do this with the least amount of writing possible. So how about we start with our drawing. I'm going to shrink this real quick so I can draw these nice long lines. How many book titles were there, I wonder? I think I have it on my notes. There's 4 books, right? We got to pick 3 of them. So that's 1. Get off. 1, 2, 3, and this would be 4. So let's just do this. So this will be our number. And this is for counting purpose. I didn't need that. So To Kill a Mockingbird. So To Kill a Mockingbird. All's Quiet on the Western Front. The Stranger. Huck Finn. Oops. There's one more. Midsummer Night's Dream. Got to go a little further, kids. So A Midsummer Night's Dream. How about that? So let's go way one. Let's just read the first three. 1, 2, 3. Way two. We're going to read the first two, but not this one, this one. And then we're going to go 3. This one, not this one, not this one, but this one. So those are all the different ways of reading To Kill a Mockingbird and All's Quiet on the Western Front, and then a third book. So now I think what we'll start on is reading To Kill a Mockingbird, not All's Quiet on the Western Front, but then these two. And then 5, this one, not this one, not this one, but not this one, this one. And then 6, this one, and nope, can't do that. So then this one and this one. So I think those are all the different ways you can start with To Kill a Mockingbird, which you should read. 7. Now we're going to start with these two and then read a third book. So how about that one? And then we're going to start with these two and read a third book. So how about that one? And then we're going to start with this one still, but not this one, and this one. So that's all the different ways to read, starting with All's Quiet on the Western Front. So now we're going to go through this one. We're going to start not here, not here. We've already read all those. This one, oh, and this one. And there's 3 books. So it looks like there's 10 ways. There are 10 different ways to read the 3 books, or to read 3 of the 5 books. And just so you know, just in case you're wondering, if order mattered which way you read the books, it would be, let's see, 60 different ways. But we're not going to deal with that. That's a different story for a different day. That's it. That's all. That's all she wrote. Those are systematic lists. You know what I'm going to say. When you finish systematic lips. Put it to your lips and drink. That's what I was trying to say. Oh my God. Classic line. Classic. Absolutely classic. Oh.